Alright, so welcome back. In this tutorial I am going to show you how to couple the gmsh mesher to create a tetrahedral mesh, and then we will turn that into a polyhedral mesh with Openfoam, and afterwards we will add layers with snappyhexmesh. So first of all you need to download gmesh. So if you go to gmesh.info you can download it for your operating system. I use Windows. You should also use Windows, hopefully, because my app uses Windows. So download this, and if you extract the file, it is, I think, a zip file. You go to settings, to third party, and you paste the path where you did save your gmesh executable. Basically it is one directory. You need to save that somewhere, and this path should lead to the gmesh.exe file, and you can either insert the path directly here or you can browse and then go to the directory. And the second thing is you need obviously a working Openfoam version. I use, and you should also use, Openfoam version 13. You can hit this button, detect installed Windows subsystem for Linux distributions, and I installed it for Ubuntu 22.04. So if I hit that, that's all I need currently. So what we need is a working example. So I will just create something that is easily accessible for a quick demonstration. So I will use the cyclone separator module to create the example shape. So let me quickly adjust a couple of values, and then I will move that to the cut environment. I will merge these two. Now I will mesh this basically. Okay, so if I go to CFD, treat head mesher, I left click on this, and then I right click on geometry and I import that. Okay, so what I have now is a 3D shape. I can basically close this and hide this object tree. So if I go to mesh, I will see like min and max size. You can create custom sizings, but I will, for a quick demonstration, just use something globally. And then if I hit now this mesh, you will see it will connect to gmesh, and it will work basically with gmesh. If it takes too long because you entered very small values and you think you need to kill the process, just hit on this and it will kill the process. So the mesh is created, but it's kind of too coarse, I guess. So let me try another values. Hit the play button again. I think that's also rather coarse, so third try. I don't want that to take a long time to finish, but it should be kind of fine to make it a good example. So okay, I think I can work with that now. Now two things are shown currently here. If I click on this eye, you see the geometry, and then if I enable, you see the mesh actually. If you want to cut through this to see what's inside, you can apply the clipper and move the clipper around and look inside. Okay, that's a tetrahedral mesh. Let me hide the mesh and turn on this. So what we need here is, I will go to face selection, and then I will click on the face here, and I will rename that to outlet top. We need an inlet. So the patch type is patch. Inlet is also patch. So what I have here is an outlet bottom. Outlet bot. Okay. So I have one inlet and two outlets. The other faces that I do not create the patch with will be automatically called wall, and these will be of type wall also, so you don't need to click everything. One thing I want to mention is, obviously I did forget to merge the shape when I fused it. Like here you see this additional face. I don't want that. I should have, if you click on that, I should have hit this unify same domain. And if you want to unify faces that lie on the same plane, basically you can select the shape and hit this fix shape, and it will fix your additional faces that you have. Sometimes you want to keep these to create additional faces, and this time I do not want to keep these. So, and also if I go here, because I did not merge the faces, you see you have these, it did respect this face here and along this, and it did basically create this tiny bad shaped tetrahedral cell. So let me select this shape, and I will import this one, and with the same settings I will then mesh again. So, and you see that these lines will disappear. It was pretty quick, so sorry for that one, but you can learn a couple of things. Afterwards we will create again the patches, and then we can move on. So okay, the meshing is done, and as you can see this time, basically you don't have these bad shapes, the bad triangles anymore. So enable the face selection, hide the mesh, create on patches, patch add, rename to outlet top. This is right click, add patch, rename, inlet, and the selection is still active, so I had the plus sign, and I can also highlight with this button, and you see the inlet will be highlighted, the patch. So hit the patch, outlet bottom, and okay, patch. Okay, that's basically it. And in the next step we need to export the mesh. So if you hit this button, it will ask for conversion factor. Now the shape I created was in millimeters, so I want to turn that into meters. So if I hit this, and I will save that basically here, and the mesh is basically saved in Openfoam native format, so I could basically hide this and go to snappyhexmesh worksheet, and if you hit on this button, you can select your working directory. You can create either a new one or load an existing one. I already load the directory I put the mesh recently, so I can directly access it, and this is my path. I don't want to show it to you currently. So once you did that and you hit this console, this will create that will mimic the terminal, basically the Windows subsystem for Linux. You see on the left side your project, so the polymesh is created here, and I could execute now like check mesh. Okay, it will connect to Windows subsystem to Linux. That we coupled by going to settings, and then we checked which distribution we installed, and the one you have Openfoam in will then be selected from this drop down menu, and then you can hit on this console button and it will then load the console, and then you can hit these buttons. These are all coming with the commands. So if you want to type something in, you can use this command line, or just use the buttons over here. If you want to see text files, you can double click, and here you will see these. So I hit on check mesh, and the maximum non-orthogonality is like 78, and everything else looks also fine. Here I see that I have an inlet patch, outlet bottom patch, outlet top patch, and wall default. I told you earlier, every patch that is not put into a patch group will be called wall default. So I can now, the foam file I have has a menu. Right click and this will appear, path to mesh viewer. If I click on this one and go to the mesh, it will call the VTK mesh viewer. So it does directly pass this file where it resides. So if I hit OK, accept, and then on this play button, it will execute and it will load the mesh. So I can change to surface view. You will basically see the mesh. Okay. So the next step is, I told you the first step we want to do is to create a polyhedral mesh. So I will hit on this gear and then polydualmesh. A window will appear. So you need to put in a future angle value, and then you have basically options here. You can test these or not. I will not overwrite the tetrahedral mesh. I will hit OK, and it will basically execute now polydualmesh. And once it's done, it creates several OBJ files and also a mesh within this directory one. So what I can do is accept selection, and it will then load for the reconstructed case the time steps. It's currently on 1, and when I load the file, hopefully it will then create a working polyhedral mesh And based on the future angle, you might get here not so edgy cells, so you can play around with the settings. For a quick tutorial, that shall be it. You can play around with like polydualmesh, I don't know, like 130 maybe, like concave multi-cells, like I don't know, keep it by 90 and test this one. And process finished, writing dual mesh to 1. So load again. So basically you can try to create a better mesh. If you want to check again, it did just destroy the mesh orthogonality. So let's stick to this value. And then check again. Okay, it did create incorrectly oriented cells. However, after creating a good working polyhedral mesh, you can also use like the snappyhexmesh worksheet. You can set it up. You go to inflation settings and you hit this plus button, and we want to create inflation for all walls like this. Then relative sizes change to no, and the absolute size will be then like 3 millimeters. And then we create 3 layers and disable castellation and snapping. And if you want to change something in the layer section in the settings, you can play around with these values, and also you can check or uncheck from here the quality metrics. And once you're done, you can hit this and it will create the snappyhexmesh file. Also, don't forget to save your settings so you can access these later if you want to work on that. So I have created the snappyhexmesh file, so no overwrite. If I click on this button, it will execute snappyhexmesh, but only the layering step because I disabled the other ones. So I'm not quite sure. Yeah, it did take the tetrahedral mesh, and I think it did overwrite the polyhedral mesh. So I should have started from 1. So it doesn't matter. I can call the polyhedral setting again. Let me actually check this one setting. If a process takes too long, just you can hit the stop button and it will interrupt the process. So Let me just change the value and call this. Let me erase the directory. Yeah. Whatever. So I cannot access somehow the. Let me try this one again. Okay. So if I set the start time now to 1 and call snappyhexmesh, it will start with the most recent mesh I have. Okay, once it's finished, we can investigate the mesh. And as you can see, it did create the layer somehow over here. And here you have some kind of collapsing. You need to play around with the settings. Now you can look inside. You have layers here collapsing at the edges, at the corners. So for a quick demonstration, it is sufficient, I guess. So thanks for watching and see you in the next tutorial.